Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we are going to answer the three questions that ask about general physics unit in May-June session 2020, paper 4.1. First of all, in this question here, an airplane of mass 2.5. Okay, this is the mass 2.5 times 10 to the power of 5 kilogram. Lands with a speed of 62 meters per second. This is U, initial speed, on a horizontal runway at time equal t0. Then the airplane decelerates uniformly as it travels along the runway in a straight line until it reaches a speed of 6 meters per second in 35 seconds. So what do we have here? We have U, V, T, and the mass, okay? First of all, they ask about calculate the deceleration of the airplane. Now we don't know that we don't have a formula for acceleration. For deceleration, we have a formula for deceleration, for acceleration, and the acceleration is the negative of the deceleration, which is V minus U divided by T. By using the formula and substituting the values that we have it, okay, what do we have? We have the value that V, it's 6 meters per second minus 62 divided by the time, which is 35 seconds, okay? And by using the calculator, our answer will be negative 1.6 meters per second square, but this is the acceleration, so we've put it as deceleration 1.6 meters per second square without putting the negative because they ask about something which is already negative. That's first part. Second part, they ask about the resultant force. Now, after we find the acceleration or the deceleration, we know that resultant force is equal to the mass of the airplane multiplied by the acceleration or the deceleration. Now we know that this resultant force, it's acting in the opposite direction since it makes it decelerates, okay? So the mass, which is 2.5 multiplied by 10 to the power of 5, that's given, multiplied by the acceleration, our answer. It will be error carried forward if we did this one wrongly. They will accept our answer here, multiply by 1.6. So the answer will be 4 times 10 to the power of 5. But we are not going to write it as one significant figure. We are going to put it as two significant figure, 4.0 times 10 to the power of 5 watt in Newton. This is the resultant force, which it's acting in the opposite direction since the airplane is decelerating. Then they ask about the momentum when the speed is how much? 6 meters per second. Now we know that momentum equal mass multiplied by the velocity. They ask about the final velocity, not the initial velocity. So the mass, which is 2.5 multiplied by 10 to the power of 5 multiplied by the speed, which is 6. And our answer will be 1.5 multiplied by 10 to the power of 6. And the unit of momentum is the unit of mass multiplied by the unit of velocity, which is kilogram/meters per second. Then they ask in part B, that's all part A, it took 6 marks. Then they ask in part B to draw a graph between the information that we have. At t equals 35 seconds, after it was decelerating, okay, because from t equals 0, under 35 seconds, it was uniform deceleration. Then what they said, at t equals 35 seconds, the airplane stopped decelerating and moved in the horizontal way, okay, runway at constant speed, okay, for another, 15 seconds. So this is 35 and this is plus 15, which is 50 seconds, okay. Sketch the shape of the graph, okay, as it travels. Now we know that it's a distance time graph. Now, for distance, if we draw a straight line, that means we are talking about constant speed. If we because it has constant gradient, but as we draw it like this, increasing gradient, the curve is going up, that means the speed increases. So this is acceleration. If we draw it like this, okay, curve with decreasing gradient, that means that speed decreases, which is deceleration. Now they ask for deceleration, that then they continue at what? Constant speed. Most of the students, what they do, they draw it like this. That's deceleration, okay? Then they draw it like this as constant speed, and that's not correct. Why? Because at this moment here, okay, suddenly there is change in speed and change in acceleration, and that cannot happen like this, okay? So what we are going to do, we are going to draw it like this. We are going to draw a curved line, okay, that still has a gradient, okay, at this moment here. Then we'll continue, okay, this line as a straight line, okay, with a ruler, okay. That means the gradient here doesn't change. So the gradient here keeps changing curved, okay. Then it becomes what? A straight line like this. Or you can make it steeper in the beginning, okay. Then here, and you make it what? Draw like this, a straight line that's still going up with the constant deceleration. Both answers are accepted, but be careful that at this moment when it reach the time of 35 seconds, the line doesn't change its gradient. It remains constant after that. Okay, that's for the first question, part A. Part B, part C, they said, as the airplane decelerates, the kinetic energy decreases, okay? So just what happened to this energy? It dissipated to heat and sound. Transfer to heat and sound. Transfers to heat and sound to the surrounding. Surrounding. Now, as you can see here, okay, in this question, part A asks about several things. Ask about the deceleration, ask about resultant force, ask about momentum. Then part B asks about the graph, distance time graph. Part C, they ask about energy. They ask about a lot of things, 10 marks question.